Welcome back to Maths with Mrs. J. We've been learning about probability, and we've learnt about using tree diagrams and grids or tables to help us list out all the outcomes that we can get in an experiment. We're now ready to start considering the fact that sometimes when you've done the first trial of an experiment, the probabilities the second time around might change. This is particularly common in a situation where you're talking about removing things from a bag, that kind of situation. If you are taking a coloured marble out of a bag, noting the colour, then putting it back, remixing them up and taking one out, the probabilities each time of getting a red, a blue or a yellow will be the same. Because we've still got, each time we're dipping into that bag, we've still got the same number of each type of marble. That's called drawing with replacement. So we take one out, we look at the colour, write it down, pop it back in, remix it up and get the second one. Those are independent events. What happens in the first drawing of a marble doesn't affect what happens in the second drawing. However, if you either take two marbles out at the same time or take one out and not put it back and then get another one out, probability-wise that's the same thing as taking two out at the same time, you're actually changing the probabilities of that second marble. If it's simultaneous, you could pretend that the second one's like a second later. Do you know what I mean? You're changing the probabilities. Now, we're going to do this question both ways. We're going to do it the first way if we take the marble out and then put it back in. And then we're going to do it without replacement. And let's just see how we go. That's called conditional probability, by the way. The first way we're doing it, the trials are independent. Doesn't matter what happens in the first one, it's not going to affect the second one. So we've got 3 red, 4 blue, and 5 yellow marbles in a bag. So the probability of us reaching in and getting a red one out would be 3 on 12, which is a quarter. Probability of us reaching in and drawing out a blue one would be a third, because we've got 4 out of 12, and we've got 5 yellows in there out of 12. Now, because we're putting the first one back in, the second time round, the probabilities are not going to change. So we're going to get a quarter, a third, 5/12, a quarter, a third, 5/12, a quarter, a third, 5/12. So the probability of getting red then red, what we do in this case is we multiply these probabilities. So it would be a quarter by a quarter, which is 1 on 16. Probability of getting red then blue would be a quarter times a third, which is 1 on 12. Probability of getting red then yellow would be a quarter times 5 on 12, which is 5 on 48. Probability of getting blue then red, a third by a quarter, which is a 12th. Blue then blue, a third by a third, so a 9th. Probability of getting blue then yellow is a third by 5/12, which is 5 on 36. Yellow then red is 5/12 times a quarter, which is 5 on 48. Yellow then blue is 5/12 times a third, which is 5 on 36, and yellow and then another yellow is 5/12 by 5/12, which is 25 on 144. So they're all our probabilities there of the different situations. We can now answer these questions here. We can do a little bit of colour coding like we have done before. So maybe do both marbles red, probability both marbles red. Okay, well, it's only this one, isn't it? So the probability of red, red already done that. Hang on, let's just go straight to equals 1 on 16. Red, then red. Probability blue, then yellow. Let's do this in brown or something. Right, blue, then yellow. Blue, then yellow is this one. So it's 5 on 36. Both the same colour. Now, both the same colour is going to encompass 3 different things. It's going to be either both red, both blue, or both yellow. So we're actually going to add up those 3. So it's going to be 1 on 16 plus 1 on 9 plus 25 on 144. We're going to put them all over 144 and come up with a fraction. I'm not going to do that right at the moment because that's going to be a bit of a mess. However, in our next question, how do you think we would deal with that one? Probability that they're different colours. Well, thinking back to our previous video, they're either the same colour or they're different, aren't they? So this will be 1 minus your answer to the previous question. Okay, let me just work out quickly what that fraction is. 25 on 72 we get for that one. So this will be 1 minus 25 on 72, which is 47 on 72. Okay. All right, so that's where the events are independent. What happened the first time didn't change the probabilities. Now I'm going to erase what we just did. I'm going to leave the basic tree diagram part there, and we're going to work out what the probabilities would be if we were to take one out and then not put it back in before we take out our second one. So bear with me, I'll just erase. There we go. Ready to go. Okay, now our probabilities the first time round are still going to be, you've got 3 reds out of 12, so it's a quarter. You've got 4 blues out of 12, so that's a third. And you've got 5 yellows out of 12, so it's 5/12 chance of getting a yellow one. Now, this is where we need to have our thinking caps on. If the first one is red and we've taken it out, how many marbles do we have left in the bag? We have 11. And how many of them are red? 2 of them are red. So there's a 2/11th chance of the second one being red. So the probability of getting red then red is a quarter times 2 on 11, which is 1 on 22. If the first one is red, we've got 11 left. We haven't taken any of the blue ones out though, so there are 4 blues still in there. So the probability that the second one would be blue would be 4/11. So the probability of getting red then blue would be a quarter times 4 on 11. 4's cancel and just get 1 on 11. If the first one is red, then the probability of the second one being yellow will be 5 on 11 because there are 11 marbles left in there and 5 of them are yellow. Okay, if the first one is blue and you want to know the chance of the second one being red, well, you've got 11 left in there and 3 of them are red. So it will be a third times 3 on 11. The 3's cancel and you get 1 on 11. If the first one is blue, then you've only got 3 blues left out of your 11 remaining marbles. So it will be a third by 3/11, which is 11. If the first one is blue, then you've still got your 5 yellows in there, but you've only got 11 marbles. So a third by 5 on 11, which is 5 on 33. Okay. If the first one is yellow, the probability that the second one is red is going to be, well, we've still got 3 reds left in there out of 11. So it's going to be 5 twelfths times 3 elevenths, which is, well, that will cancel with that. So we're going to get 5 on 44. If the first one is yellow, you've still got 4 blues out of your remaining 11. So it will be 5 twelfths times 4 elevenths, they cancel. So you get 5 on 33. And finally, if the first one's yellow, you've only got 4 yellows left now out of your 11. So it will be 5 on 12 times 4 on 11, they cancel. So you get 5 on 33. So do you see, it's not that difficult to do if you just think to yourself, okay, well, how many reds do I have left and how many marbles total do I have left? Okay, and if you just think that through, but you can see that these are different probabilities from these ones. What happens the first time round has affected this time. They are not independent. Okay, let's do this. Probability that they're both red is our 1 on 22. So first one red times second one red is 1 on 22. Probability of blue then yellow. Blue then yellow, 5 on 33. So the first one being blue, second one being yellow. Probability of both being the same colour, that's going to be this one. They're either both red or both blue or both yellow. So we're going to add these up. So what have we got? 1 on 22 plus 1 on 11 plus 5 on 33. So on 66, what are we going to get? 19 on 66. And then this one again is still going to be the complement. So it'll be 1 minus probability same, which is 1 minus 19 on 66, which is what, 47 on 66. Okay, so there's your conditional probability. And you multiply through each time, but you add if you've got like probability of this or probability of that or probability of that. Okay, getting a little bit tricky now, so we need to be doing lots and lots of practice.